Hi, Assalamualaikum. We are from Group 2 from Class 2B3. We are doing Lab Center of Pressure. My name is Muhammad Lokman and here's my next group member.
Hi, my name is Nurul Nabila Kamel and this is my next member.
Hi, my name is Nusafina binti Muhammad Karnaki and my next team member.
I'm the last team member. My name is Warisma binti Kardin. So enjoy our lab video.
I would like to present about introduction for this experiment. We focus on determining the center of pressure on a vertical rectangular surface submerged in water. The objective is to understand how hydrostatic force act and where this force is applied on the surface. This activity also support the development of independent learning and critical thinking, as is it part of an open-ended laboratory required by the EAC accreditation. In this experiment, we will compare the experimental result with theoretical calculation for both fully the partial submerged condition and analyze any difference between them.
The center of pressure is the point on a submerged surface where the total pressure force acts. When the flat surface is placed on water, the pressure on it increases with depth. The deeper you go, the higher the pressure. This means the force from water is not spread evenly. It is stronger at the bottom than at the top. Because of this uneven pressure, the center of pressure is lower than the center of the shape. In the experiment, we want to find this point by balancing the force. We submerge a plane surface in water and use weight to balance the moment caused by the water's force. By doing this, we can measure where the total force effectively acts and compare it with the calculated position. This will help us understand how pressure varies with depth in fluid.
Before we do the experiment, we need to know the precaution. First, we use the safety equipment like wearing the safety jacket and then the shoes.
Next, we have to check and prepare all the apparatus to make sure the apparatus is not clean and not damaged.
Welcome to the Center of Pressure Lab. Let's look at the apparatus. This is the bubble level ensures our setup is perfectly horizontal. This is the quadrant plate, the main surface for the water force. The pivot allows the quadrant to rotate when force is applied. Here's the counterweight pen, where we add weights to balance. We use these calibrated weights. Let's add one now. Don't forget, we'll pour water here to test the center of pressure. First, we start by measuring the length of the quadrant using a ruler. Then, we proceed to measure the width of the quadrant carefully. Finally, measure the height of the quadrant from its base to the top edge.
For this experiment, we used loads of 1.0 Newton, then water was gradually added to the tank until the balance rod reached equilibrium. The recorded values for Y1 is 0.129 and for Y2 is 0.071.
For the center of pressure experiment, we use a load of 2.0 Newton. And then we adjust the balance arm and put the water. The water surface to the base of the quadrant was at 0.097 meters. And then distance from the pivot to the water surface was 0.103 meters.
Lastly, for weight of 3.0 Newton, we repeated the same procedure and take the data of Y2 and Y1, which is 0.122 and 0.078 in meters. Lastly, for the result and analysis, based on the experimental, we got the data for the calculation. For the example calculation, I used weight of 1 Newton. First, for the area, B multiplied D and we got 0.0075 meters square. Next, for the Hg, Y2 minus D divided by 2. And for the Y2 we got from the data, the answer is 0.021 meter. Next, for the force, we use formula rho G HGA. 100 multiply 9.81 multiply 0.021 multiply 0.0075. And the answer is 1.1 Newton. For the Y, we use formula of weight multiply length over force, which is 1.0 Newton multiply 0.285 meter over 1.55 Newton. Answer is 0.184 meter. Next, for the experimental depth, we use formula of Y minus Y1, which is Y1 based on 0.2 minus y2. And for the theoretical depth, we use Hg plus Ig multiply A Hg. We have to calculate Ig first using formula of B multiplied D power 3 over 12. Then we insert the answer of Ig into the theoretical depth formula. And we got the answer for theoretical depth is 0.061 meter. Last part is to calculate the area of theoretical and experimental depth. Based on the formula, we got the area for 1 Newton is 9.84%. Next, I insert all the answer into the table of 1.0 Newton. Not just that, I also calculate for 2 Newton and 3 Newton, and all the answer I insert into the table. Lastly, the percentage error for each weight is 9.84%, 6.15%, and 1.19%.
Now, we explain about discussion. The experimental finding demonstrate a close correlation between the theoretical and experimental depth of the center of pressure. Other than that, the percentage error decreased with increasing applied weight from 9.84% at 1 Newton to only 1.19% at 3 Newton. The discrepancy may be attributed to limitation in measurement precision, slight instability of the water surface, and possible friction at the pivot point of the apparatus. Furthermore, the data confirm that as the depth of the center of gravity increased, the hydrostatic force also increased in accordance with established hydrostatic theory.